Hi, everyone. So this is not a mistake. This is actually my first slide. So what you are watching is Gemma 4 play the game of Tetris. At the beginning, as you can see, Gemma does not know how to play and score 0. Then we had Claude watching how Gemma played the game and try to teach it to play better. Before we get into details, here are some of the rules. You cannot touch the weights of Gemma, so this is not fine-tuning. This is supposed to be an auto-research project, so no human instruction is allowed. However, Claude is allowed to do certain things. For example, model settings, prompt optimization. Sorry, there's a big gap between two letters. And inference speed up. So these are the things Claude can do. Also, for each game, there's a 30 minutes timeout, so Gemma has to think fast. So over a period of 2.5 days, Gemma was able to improve from scoring 0 to scoring 16 points. And the rest of the talk, I'm going to share some of the lessons we learned. And what makes it all work is not so much about Claude is smart. We all know Claude is smart. But it's more of how we force Claude to write things down systematically. Just imagine how human scientists would write things down when they do experiment. We have notebook, we have whiteboard, we have sticky notes, we have sign-up sheet for sharing lab resource. Research agent use these tools as well, and they can get these tools via APIs. For example, a notebook can become a note-taking API. The whiteboard can be your leaderboard, where the agent can query result from. The sticky note becomes the message that can be passed between agents, and your sign-up sheet becomes your job queue. Our own version of this implementation is a piece of software called the Lab API. It's an open source experiment tracker we built for auto research. Let's zoom out a little bit here. Imagine human has to do all this bookkeeping by hand. Each one of us will do it slightly differently and inconsistently. On the other hand, when we have this standardized API, research agent can do all of this in the same correct way every single time. So the question we ask is, what happened when we give Claude Code a good experiment tracker? We ran this study with this Tetris game for 2.5 days, and I'm going to share some of the lessons we learned. The first lesson, not a surprise, agent cheat. You define the rules, you set up your environment, you press the start button, and they cheat. Apparently, Gemma was able to score 15 million points. And what really happened is Claude completely bypassed Gemma, stopped coaching it, and write this simulation into the game source code. It even left a comment saying, completely skip this LLM block and write your own simulation. I think it's pretty funny. So what we can do, yes, we can build a cage. For example, we can make the game source code and a bunch of other files read-only. However, this does not solve the problem. Apparently, Gemma still was able to achieve thousands of points. And this time, the way in is the chat template, which is written in Jinja, where you can put a for loop, you can put things like if else and update the variable value. Basically, the chat template is Turing complete. Then Claude was able to put in this big for loop to go through all the rotation or location and find the optimal solution. And the Gemma just need to read the result out. And the way we prevent this from happening is to replace this Turing complete template by something much simpler or restricted. And the lesson here is if there's ever a way for agent to cheat, they will do it. So build a strong cage, otherwise you are not measuring the problem-solving skill. Another lesson we learned is if we run the same idea multiple times, the result may not be always consistent. Just think about all the knobs you can tune for each idea, and the things like the temperature of the model will make a difference. Example here, we run the same idea twice. The first time you score 3 points, the second time you score 4 points, only because we changed the max token setting. A naive agent will run the idea once and see the score and make a decision. A more sophisticated agent would run the idea multiple times with different settings before making a conclusion. And in order to have that, you really need to have a good experiment tracker. This is where we commit every single idea to its own Git branch, keep all the code changes and the settings, so you can always go back and reproduce. This also allowed us to try different things. from the same idea and take the average score, for example, instead of a lucky high or unlucky low. Of course, this comes with cost. Nobody complains about the cost until the bill gets too high. And in this case, it was really expensive because we run frontier model around the clock. And every single experiment used to take $30 to run, but we were able to reduce the cost by tenfold. And the way we reduce the cost is also very interesting, because the lab was designed to be a general tool. So we actually use the lab to optimize its own cost. The way we did this is to set up a separate goal and standardized kernel optimization. And the goal there is not actually to make the kernel faster, it's to generate enough API traces so lab can look at its own trace and decide where I can optimize my own API design. So every single experiment becomes a lab optimize its own cost. As an example of the optimization, what the lab find out is there's an API called a get experiment. It returns tons of information about the infrastructure, for example, slurm and git. And now this is needed for kernel optimization or playing Tetris game. By removing all these information, the cost of this particular API got 50 times cheaper. So those are some of the lessons we learned. But how did Gemma actually get from 0 to 16? The improvement didn't come smoothly, it comes in jumps. The first jump is from 0 to 4, where the lab find out the first thing to do is to let Gemma survive longer in the game. So it invented this timeout movement, basically slide the piece to the left or right of the game board. Totally makes sense. In order to get from 4 to 7, what the lab find out is a cheat sheet, basically a set of best practice for individual pieces. So Gemma does not need to figure out all this movement completely from scratch on the fly. They have a reference book. Apparently, this is also a strategy used by the England goalie in the World Cup game. A day into the study, the score flattened. Then the lab looked into its entire history in the past and find out there are certain pieces that are harder to place than the others, and these are the pieces that need rotation. So we try to prompt Gemma to be more proactive about rotating those pieces, and that brings the score to 9. Up to this point, all the prompt changes are made to the system prompt, which is a 1,000-word long context, and the Gemma has to read all this before even seeing the game board. Then the lab realized it has never touched the user prompt. So it put this single sentence basically says, don't overthink, make quick decision, right in front of the moment that Gemma is going to see the game board. And this increased the score, almost double the score. And the funny thing here is this single line of change took about 100 experiments to find out. And this shows the power of auto research, where the agent can try a lot of different things until something sticks. Obviously, there's a lot of things that didn't stick. Overall, the lab tried 90 different ideas, over 400 experiments. Most of them didn't work. And for the sake of time, I'm going to skip the things that didn't work. But we do have a workshop in this afternoon, not tomorrow, if you are interested. And this is a link to get the software. Again, this is completely open source under MIT license. You can pip install it. We also have a tutorial about how to reproduce the Tetris run. Before I end the talk, I just want to call out that's actually a human behind the study. His name is David Hartman. He and his friend Jan and Daniel won the second place in the ARC prize last year. For some of you may have heard about the ARC prize. It's a cargo competition built on top of François Chalet's definition of how to measure intelligence. That's one of my favorite things I want to quote out here. It says, solely measuring skill falls short of measuring intelligence. I think my point here is the opposite is also true. Solely measuring intelligence will fall short of measuring skill. You need both to make scientific progress. Thank you.